Alright, hello and welcome everybody to the first companion video designed to go with the How to Exploit Binary repository that I've created. I'm glad you are here. I'm glad you are interested in a very important aspect of cybersecurity, and I really hope that I'm going to give you a good start, sort of a good place to get your feet wet and really understand how things work under the hood and maybe learn a bit more about the nitty-gritty details that you didn't know. So without further ado, we're just going to jump right in. So first thing you're going to need to do is get onto your Linux machine. I don't actually have a Linux machine. This is OS X. So I have a virtual machine. I suggest you get one if you're running Windows or OS X. Tons of free software that can do it. VirtualBox. I use Vagrant, so I'm just gonna do Vagrant SSH, and it's gonna pop me into my Linux VM. So first things first, we're in here. I have already run the setup script. So I suggest that you just take a look at the setup script. If I just go back here, the setup script, I just recently pushed it. It has just all the dependencies that you might need for anything referenced in this video are installed with this, and so this is just a quick way to get you set up. So all you'd have to do to get this to run is copy this into a file and then execute the file. And if you need any help with that, I guess just comment on the video. I'd be happy to explain it if you're new to Linux. So, assuming you've already done that, we can now go into the first exercise. Sorry, the first intro. Not quite the first exercise. So the first intro, I suggest you read it. It's got a little bit of write-up stuff, but I'm going to sort of go through and explain what's happening. So we are going to go in to the repository cd how to exploit binary intro 1. Once you're in here, you'll notice, after I get rid of this thing, because I was in here before setting up, but once you get in here, you'll realize there are three things. You have the README file. That's just some, GitHub boilerplate. That is this. You'll have your helloworld.c, which is your source file, and helloworld.bin. You will not be able to execute, most likely not be able to execute this bin file right away. Compiled code, machine code, highly architecture dependent, very platform dependent. It is not cross-platform at all. So if it does run for you, it's 1 in 1,000 odds. So in order to get a bin that you guys can actually run, we're going to copy this command, right, and we are going to run it. So this is gcc tac-m32 helloworld.c tac-o helloworld.bin. So basically what this does is this tells gcc that we are going to compile in a 32-bit format the helloworld.c file, and we're going to name the output, tac-o for output, helloworld.bin. So this just replaces the little placeholder binary that I've included with one that you can actually run. So if you test it, /helloworld.bin, magic, you got hello world, right? This is everybody's first program. So if you just cat out the helloworld.c, it's simple, right? You have an include statement, you have main, you have this call to printf, and then that's it. So without any more hesitation, we're gonna actually try and understand what's really going on behind all of that source code, right? That source code is just, really sort of abstracts away. It hides the things that are going on in the background, but we want to learn. So we're going to do gdb helloworld.bin. And the .bin suffix is very common. It's not actually a file format. It's just designating, really for humans, that this is a binary file. So first thing you notice is the peta prompt. GDB peta pops up in this wonderful, beautiful red color. I use peta and GDB interchangeably because they're just so intertwined in my mind, because I use them together all the time. So if I refer to one or the other, don't be confused. It's all the same thing. So the peta prompt is nice. You can clear the screen, which is so nice. You don't really know how bad it is unless you've already struggled through GDB, but I'm gonna give you that shortcut out because nobody deserves to suffer through GDB without peta. So the first thing we're going to do, set a breakpoint. We're going to do b asterisk main, and basically this says this b asterisk is set breakpoint. This b asterisk set breakpoint, and then main is the name of the function. So we've set this breakpoint at this address. That's telling us the address of main. We're going to hit R, which is shorthand for run, and then enter. And immediately you're going to see that these three sort of sections pop up, right? We have up here registers, we have code, and we have stack. So very briefly, registers are little bits of memory that are actually on the CPU, typically sized in 4 or 8 bytes. If you're on a 32-bit binary or 32-bit system, right, they only have 4 bytes. And then, yeah, so registers basically, if you have to do a lot of manipulations, you don't want to use RAM, it's really slow. So we do, some operation to pull a value out of memory. We put that value into a register, we do our math, we do our manipulations lightning fast, and then we put it back when we're done. Where do we put it back? Well, usually onto the stack. So the stack is one of two main sections of memory in a program. The stack is like very immediate to the program, so local variables and such get sort of thrown onto the stack. And this will usually contain a lot of like useful contextual info about how the program is running and what variables are stored. And then last but not least, you have code. So this little arrow is saying, hey, this is where we are, this is the address, and this is the start of the function. And then usually these +4, +7 are just like the address plus that value. So it sort of gives you information about what function you're in. So what you can do now is NI, that is next instruction. And I'm just going to explain this first instruction to you. I'm not going to explain the whole thing. But LEA is load effective address, so it's going to load the value of ESP +4 into ECX. So if you look at ESP, we're at 5FC. If you add 4 to that, you get this value, FF at D600. So if we do NI and run it, you'll notice that now in ECX is that value. So I'm not going to explain every instruction here. That would take a very long time. I'd encourage you to run through this program and look up the instructions. There's documentation out there that can help you better than I could. And eventually you'll get an intuition for these sort of things and what they're doing. So we can continue stepping through this program. We get a call to puts. And the cool thing is Peta gives us these guessed arguments. There's another reason Peta is excellent. You see puts, you're like, wait a second, we use printf in the C source. What's up with that? Well, that's a compiler optimization, so compilers are really smart. If they see that you're calling printf on a string that doesn't have any like format strings, it just calls puts instead because it's a faster method. And you can see the argument, okay, we're calling puts. What are we calling puts on? arg0, hello world. Very straightforward. We can go through these next instructions. You'll see we have leave, we have this little LEA instruction, and then ret is return. And when main returns, the program's actually not quite over. libc start main is the precursor to main. libc start main calls main. Main returns, that's how you can return with errors and not have the program, explode. So libc start main is going to basically check the return values and make sure that everything's in ship shape, and then it does a little bit of cleanup, and then you see this call to exit, and hey, not running or target is remote. So that's actually the end of the program. So yeah, that is Peta. GDB Peta, super useful. I'm going to very briefly show you what GDB is like without Peta, just to congratulate you on having avoided using regular GDB. So if I go back into my .gdb init file, and I comment out that source Peta, it's not going to run it with Peta, so it's just going to be vanilla GDB, and you'll see, wrong one. You'll see that GDB is a lot more painful. So if I set that breakpoint again at main and we run it, wow, look at that, no information. If I want to learn what's inside the registers, I got to do info reg every time. If I want to know where we're at in the code, I have to do disass main, or whatever function we're at, but I have to disass, right, every time. And this gets to be a real pain. So yeah, GDB with Peta is much nicer than regular GDB. It's very straightforward, and it makes the debugging process much less painful. So I'm just going to go and quickly uncomment this line. And that is it, folks. So my challenge to you is to run through that program until you know every instruction in it and how it works, because this isn't going to be it. You're going to see tons of these instructions, and you're going to have to know what they all mean. And x86 is a big, complicated, awful architecture, so there's tons of instructions. You don't need to know them all, but you need to know common ones. My other challenge to you would be to do this with more than just one program. So I gave you a hello world program. That's very simple. There's no loops, there's no if statements or any sort of a structure to the code. It's just straightforward, straight line execution. I'd encourage you to maybe write a program that has like a switch case or some if-else statements and see how those work under the hood. And I would encourage you to also make a program that maybe has two sets of loops, like a nested loop, or looping over an array of some sort, or maybe make a program that prints all the Fibonacci numbers and learn how that works. That sort of introductory understanding of how assembly language works, which is what we're looking at, that assembly language, that's going to come with time. It really is a process to sort of be able to look at something and intuitively get how it works. But hopefully this is a great way for you to start getting your feet wet with binaries in Linux. So thank you so much for watching this. I hope it was a good start for you. I hope this video was straightforward and easy to digest. This is Bretley signing off.